Unit 5, Sequences and Series.
Intro to sequences. So there's two types of sequences, arithmetic and geometric. With arithmetic sequences, you add a value d to get the next term, where d equals common difference. And for geometric sequences, you multiply a value r to get the next term, and r equals common ratio. And the other standard variables are a sub 1 equals starting term, a sub n equals the value, and n equals the position.
Arithmetic sequences. There are two types of arithmetic sequences, explicit and recursive. The explicit equation is an equals a1 plus n minus 1 times d. Given the sequence 48, 45, 42, and 39, plug these numbers into the explicit equation. An 48 equals a1, the beginning term, plus n minus 1 times d, which is the common difference, which is negative 3, because each of these numbers is going down by 3. Okay, finding a1 and d. Given a3 equals 5 and a5 equals 11, plug these numbers into the equation. 11, which is the, oh my god, a5, which equals 11, equals 5, which is the value of the beginning term, plus end position minus beginning position times d. Do the algebra down, d equals 3. 11, which is the a of n, which is the value of the n term, equals a1 plus the n position minus the minus 1 times 3. Follow the algebra down, a1 equals negative 1. For recursive, the equation is an equals an minus 1 plus d. If a1 equals 3, a2 equals a2 minus 1 plus 2, if you plug the numbers back into the equation. Follow it down, a2 equals 5. Given the terms a2 equals 6 and a3 equals 12, plug these numbers into your recursive equation. a3 equals a3 minus 1 plus d. Follow the algebra down, your d equals 6. a2 equals a2 minus 1 plus 6. Now you're solving for a1. Follow the algebra down, a1 equals 0.
Geometric sequences. So for the explicit problem for geometric sequences, we have to find a1, and you're given an, which is 3,888, n, which is 5, and r, which is 6. So you use the explicit formula and you substitute in the values that you're given, and if you work it out, a1 equals 3. For the recursive one, you have to identify the common ratio and find the next two terms. Given the sequence -1, -6, -36, and -216. So a1 equals something, an equals an minus 1 times r is the recursive formula. So to find r, you have to divide, and you have to find the common ratio, which is 6 in this case. And then to find a5, you have to substitute the numbers into the recursive formula. So we did that here, and we found a5, which is -1296, and same thing, we used a5 to find a6, and we got that as -7,776.
Intro to series. A series is the sum of indicated terms of sequences. In a finite series, it has a beginning and an end. For example, 2 plus 4 plus 6 plus 8. An infinite series has no end and only a beginning. For example, 2 plus 4 plus 6 plus 8 plus 10 plus 12, etc. Summation notation is a form of writing a series using the Greek letter sigma, which stands for sum. In summation notation, above the sigma is the ending position, and below the sigma is n equals whichever number the starting position is. both of these will be a number value, and to the right of the sigma there is an equation. For example, if there was a 7 over the sigma and an n equals 2, under the sigma, the starting position is 4 of 2, and then the ending position is 4 of 7, and this is because the equation is for n, so you substitute the value in, so 4 times 2 plus 4 times 3 plus 4 times 4, and so on up to 4 times 7. Then you just add up all of the numbers together, and that is your sum. The sum is 108 for this series. And for the second example, it's the same thing. The starting position is n equals 3, so that's where we started here. And then the ending position is 5, so that's where we ended here. But the difference here is the equation. It's now 2n minus 1, so you just follow along with that. So 2 times 3 minus 1, then you go to 2 times 4 minus 1, then 2 times 5 minus 1, and then you follow through, which becomes 5 plus 7 plus 9, and this equals 21, so the sum of the series is 21.
Arithmetic series. This is finding the sum. The equation is Sn equals n over 2 times a1 plus an. Given the summation notation form, find the sum. You're trying to find the sum of the first 8 terms. The 8 above the sigma is the ending position. So when you plug the numbers into the equation, the sum of the first 8 terms equals 8 over 2, because 8 is n, times n, the beginning position is, to find the value of the beginning position, you take this and you take n equals 1 times the equation. That's how you get a1 equals 3. Then to get a of n, you take 8, which is the end position, multiply by the equation, you get 24. 8 over 2 is 4, and 3 plus 24 is 27. Multiply these together and you get 108. Given this series, put this series in summation notation form. S of 15 equals 15 over 2 times 4 plus 60. To find, you must be wondering, find 15, plug that into your explicit formula. 60, which is the value of a of n, equals the beginning value plus n minus 1 times 4, which is your common difference. 60, the 4's cancel, equals 4n, n equals 15. You take this number and put it for the end position at the top of your sigma, and n equals 1, because that's your beginning position. 4n, your equation is 4n because your common difference is 4 in the series.
Geometric series. So first we're going to find the sum of n terms using summation notation. So this is a given series in summation notation form. So first we can see that a1 is 5, r is 2, and n is 4 because this is the ending position. And then you take the sum of a finite geometric series formula and you plug these in, and then the sum of the first 4 terms of the sequence is 75. Alright, writing a given series in summation notation form. So this is the given series, and we're going to put it in summation notation form. So we can see that a1 is 7, r is 3, and n minus 1 is 5, so therefore n is 6. And we get here by, first, the ending position is 6 because n equals 6. The starting position is n equals 1, and the equation comes from right here. And that's our answer. So finding out if infinite geometric series is converging or diverging, and if it's converging, we have to find the sum. So this is a given series, an infinite geometric series, and a1 is 3, and we can see r equals 1/3 because it's being multiplied by 1/3 every time. And since this is getting closer to 0 as the series goes on, it is converging, and so we can find the sum. So we use the sum of an infinite geometric series formula. We plug the numbers in that we found right here, and we get that the sum is 4.5. So with the second series, this is 3 plus 6 plus 12 plus 24, and so on. So it is diverging because as it goes on, the series is going further and further away from 0. So we don't find the sum of this one. Okay, here are a couple of problems for you to try on your own, and we're gonna and you can pause the video, and we will show you the answers. So we're showing you the answers now.
Here's what we covered today. We went through arithmetic series, geometric series, finite and infinite, arithmetic sequences and geometric sequences, both are explicit and recursive, summation notation, and the you try review problems.
Thanks for watching.